students, so we didn't get to finish the back side of our section 5.4 notes, so we're going to do that now. We learned that there are some other options when it comes to solving systems of equations, that you can have also a system with no solution, when the lines are parallel, or infinitely many solutions. Infinite. And remember, no solution is when the lines are parallel, and infinitely many solutions is when you have the same line. We learn how to identify that when you have a table, when you're given a graph, or when you're just given the equation. But when you're solving like normal, you may have a system of equations that has no solution or infinitely many. Let's see what that looks like. So for this first example, if you notice, this is set up perfectly for a substitution. You've got y equals negative x plus 3. So everywhere I see a y in the bottom equation, I'm going to substitute in negative x plus 3. So let's do that. 2x plus 2 times negative x plus 3 equals 4. We'll get 2x minus 2x plus 3 equals 4. 2x minus 2x. Oops, this is not 3. I'm sorry. My apologies. I made a little mistake right here. This should be 6. My bad, because that 2 goes inside both. 2x minus 2x is 0. So then I get 6 equals 4. When you come down to something like this, that is a statement, you ask yourself, is this true or not? And this is not true. 6 does not equal 4. So when you come down, when you get a statement, which means you have no variables left, if it's a true statement, you have infinitely many solutions. If it's a false statement, no solution. So for this particular example, since this is false, this system has no solution. These two lines are parallel. All right, number 2, this is also set up perfectly for substitution. Y equals negative x plus 2 everywhere, or negative 10x plus 2. Everywhere I see that y, I'm going to plug in negative 10x plus 2. So let's do that. 10x plus a negative 10x plus 2 equals 10. All right, negative 10x and 10x gives me 0. So 2 equals 10. I ask myself, is this statement true? And the answer is no. That's a false statement. So how many solutions are there for this system? There's no solution. All right, for this last system, it looks like I'm going to set it up to solve using elimination. I'm going to multiply this top equation by 2. And we'll get out 2x plus 2y equals 6. And the bottom is 2x plus 2y equals 6. If you notice, this is the same equation. So we've got infinitely many solutions already. But let's say you didn't know that. We would say, oh, we're eliminating right here, same sign, subtract. And we would say 2x minus 2x is 0, and 2y minus 2y is 0, and 6 minus 6 is 0, and 0 equals 0. This is a true statement. So that lets me know I have infinitely many solutions for this system. Last one, we're going to solve looks by elimination here. I've got the same terms already right there. Same sign, subtract. Y minus 2y is a negative y. And 3 minus 4 is negative 1. Y equals 1. Pick an equation to substitute back into. X plus 1 equals 3. X equals 2. So this was a one solution situation because our variables did not cancel out. So this is a really quick video, but the important part is that when solving a system of equations the way that we have been, if you come down to some kind of statement and it's false, we've got no solution. If you come down to some kind of statement and it's true, you have infinitely many solutions. All right, go ahead and practice, and I will see you guys on Thursday and Friday.